oxygen or phosphorus. So it's referred to as the building block of life due to its unparalleled ability to form stable bonds with many elements, including itself. This property enables the formation of a diverse array of organic molecules, which are the foundation of known life forms. Carbon's role in creating complex molecules such as DNA, proteins, and carbohydrates is essential for the structure and function of living organisms. The ability of carbon to engage in versatile bonding arrangements underpins the complexity and diversity of biological organisms. So we are carbon. Humans, along with other living organisms, are primarily composed of carbon-based compounds. Carbon atoms are integral to the structure of DNA, off to the right, the molecule that carries the genetic information, and to proteins, which perform a vast array of functions within the body. Carbs, or carbohydrates, which provide energy. Lipids, fats, which form cell membranes, are also carbon-based. This elemental makeup underscores the fact that carbon is not just a component of life, it's the very essence of life, facilitating the complex biochemical processes that sustain all living things. So we're not like joking around up here, talking about something which could happen. We have studied carbon, and scientists have studied carbon for decades, well, almost centuries now. And we're just beginning to understand its complexity. But yet, we're always looking for the next greatest thing, but it's already here. We just haven't figured out how to utilize it yet. And that's kind of what I'm here to discuss, is how to utilize what we already have, and how to then replant back into the soil organic complexes so that our foods can then contain the very thing that we're depleted of. Organic minerals and complexes and things that happen, but we don't really talk about it. We just talk about, like, man, I gotta have the latest version of vitamin C, and I gotta have, this story goes on and on. But we need to spend more time studying the molecular composition of what we're made up of to see what we need. What are we made up of? Okay, that's the beginning. Okay, now spend the next 20 or 30 years to figure out what we're really made up of. Then we can maybe begin to have a conversation, a debate, and discussion about what we need. But it's all here. I guess if I'm allowed to say God, gave it all to us. So now we just have to figure out again, where did it go? And how do we get it back? Because that's the basis of life. It's the absolute basis, scientifically. White papers, everything of life. Now let's figure it out. Let's figure that out. So, just for fun, I didn't draw it, but I just threw it in there. Not that anybody really cares. I like the colors personally. But anyway, it's a cool looking thing, chart. I like it. I did put this together. We're not going to talk about it, but it's the carbon-silicon relationship, and there really is a pretty interesting relationship between carbon and silicon. Silicon has twice the certain atomic number, +2, so it's almost twice the atomic number. Anyway, silicon has a lot of very interesting components in it, and I've spent a lot of years looking at silicon. I don't have time to talk about silicon, but just understand it's kind of cool. And if you're kind of like a geek like me, then we can talk about the slide sometime. You can come on over to the booth. We can talk about the slide. But yes, yeah. Tell me.
One of my many questions for you is on
It's a whole conceptual, potential, great question. There's a definitive relationship. Her question is trying to get the relationship and understanding the depths of the relationship between silicon and carbon. This just starts that conversation, but that's probably something you and I will have as soon as the class is over, because silicon is such an important element. Very different though in some ways, but also, man, uncannily similar to carbon. So there's a lot to be learned from silicon, but yet very different than carbon. Silicon is not necessarily the basis of life. But man, from a molecular structure perspective, the atomic mass is just slightly that of carbon, like meaning 2 plus a little bit of carbon. So there's a lot of similarity. Carbon's 12, silicon's 28, up on there I think, 28. But anyway, we can talk about that. Moving on, This is a good screen. I like this one. It's just a recap in a sense. But not all carbon is created equal, right? Now you understand that. There's carbon which is based on living, and then there's carbonate which is based on what? What? Inert materials. Things that are not alive. But it's got the cool word carbon in it. So synthetic carbon and carbon found in living organisms, while chemically similar, differ significantly in the origins and applications. Synthetic carbon, basically carbonate, is produced through the industrial processes, such as the creation of graphite, carbon nanotubes, or synthetic diamonds, where it is engineered to meet specific physical or chemical properties. Those forms of carbon are often used in high-tech applications, from electronics to material science, due to their engineered precision and performance. But on the other hand, organic carbon, found in living organisms, is part of a very complex biochemical system. And in nature, carbon is integral to the organic molecules, such as carbs, carbohydrates, such as proteins, nucleic acids, which are essential for what? Life processes. The biological carbon is involved in dynamic processes like metabolism, cellular functions, and there's a vast utilization of carbon throughout our bodies systemically. So synthetic carbonate is designed for particular uses. Biological carbon plays a fundamental role in sustaining life and enabling the vast diversity of living organisms. So what is an organic carbon? There it is. There's a quick definition of inorganic carbon, but we've already covered it. It's inert materials. Organic compounds are carbon-based compounds that are primarily made of carbon and what? Hydrogen. Right? When carbon bonds to hydrogen, we know we have a very different form of carbon. So inorganic carbon is carbon extracted from ores and inert materials, as opposed to organic carbon found in nature through plants and living. I don't know why I did that. But that's okay. Anyway, so we've got that down. This is interesting. The computer screen, everything that you're touching is made up of what? Carbonate, right? So I want to just take a second, because I remember last year we talked about it briefly, and a lot of people came up to me after class, and they wanted to understand this whole carbon neutral concept. Has anybody seen the carbon neutral? I promised them yesterday that I would throw that in somewhere. Carbon neutral. Has anybody seen that on water bottles, or I don't know, like Evian or whatever it is, but there's a lot of information being exchanged now. If a company is carbon neutral, if a company is producing products that are carbon neutral, ever seen it on a supplement or a water bottle? Anybody? Anybody at all? Okay, one person. So this is worth covering. Gatorade. Okay, okay. Actually, I don't know that it's actually on a Gatorade bottle, but the interesting thing is that carbon, as we said, is made up. We're made up of carbon. We are made up of living methyls, aromatic coordinates, heterocycles, carbonos, carboxyls, quinones, all this cool carbon-based stuff. Carbonate is not. So when they say it's carbon neutral, that kind of gives it, I'm sorry, but I don't know if you guys agree, that kind of gives it like a little bit of a negative connotation. Would you kind of sort of agree with that? Like if somebody says carbon neutral, because now I'm thinking, here I am spending my whole life basically studying carbon, and now the latest commercial on TV says, well, we're carbon neutral. It's like, whoa, that caught me a little bit off guard, and I didn't really understand that until I started like reading into it. So here's the misconception, here's the misnomer. Carbon neutral means, and this is, God, this is frustrating. So carbon neutral means carbon dioxide neutral. Oh, but you know what? That's like too much of a word, right? Like too. It's well, that's too wordy. Carbon dioxide. That's just too wordy. It's just so much better just to say carbon neutral. This sounds better, but that's unfortunate because that's a scientific inaccuracy. That's medically inaccurate. But from a marketing perspective, well, I mean, I guess it's kind of cool because something's carbon neutral, it's easy to say. But scientifically, medically, carbon neutral is meaning carbon dioxide neutral. And carbon dioxide is stuff that is fossil fuels are burned. It is the remnants of ash and the inorganic carbon that's used for what? Gas, ethanol, fuels. When you see factories and smoke coming out of factories on pictures, they're burning what? A form of carbonate. But that carbonate is producing CO2, carbon dioxide. But again, it's a lot easier, I think, to just say we're carbon neutral, but that's ridiculous. No, we're made of carbon. Don't ever buy that into that. We're made of carbon. It's a scientific fact. I've studied it all my life. And I can tell you carbon neutral means carbon dioxide neutral. So don't get confused if you open a bottle of water someday and it says carbon neutral. You'd be like, oh, I remember that doctor dude from the anime told me about that. Yeah, well, now you know. So the cat's out of the bag on that one. So the carbon cycle then unfortunately produces what at the top of the screen? CO2. But really, I put that on there as a joke. Well, it's not very funny. But I put carbon on there and why? And I should have put what? Carbon dioxide cycle. Okay? But I just left it there because that's, that's what it is. Because I wanted you to see it and understand that carbon and carbon dioxide, they're not the same thing. One is what? A derivative of the other. But we're not made up of carbon dioxide. We're made up of methyls and protonates and carboxylic groups. And anyway, we're not made up of CO2. But when there's greenhouse effect and when we're burning in airplanes or utilizing fossil fuels and when we're doing all the manufacturing that we do,